Hi, my dear students. In this session, I'll be explaining about hyperbolic functions. You know something about hyperbola? It looks like this. Okay. Now, let us consider this sine of, that is hyperbolic sine function of x. It is represented in this way. Okay, so it goes like this. Right? And the cosine will be, that is hyperbolic cosine of x is represented in this way. Then you know very well the ratio between hyperbolic functions of sin x and cos x is tan x, that is hyperbolic tan x. So it is represented in this way. Now first of all, let us explain about the hyperbolic function, how it is represented. See, the quantity e power x minus e power minus x divided by 2 represents hyperbolic sine function of x. Similarly, hyperbolic cosine function of x is represented as e power x plus e power minus x whole divided by 2. Now based on this, we can find out the hyperbolic tan x. So this is the equation number 1, 2. You can divide 1 by 2. So that you are able to get e power x minus e power minus x divided by e power x plus e power minus x. So 2 and 2 are cancelled. And similarly, we can represent the reciprocal of hyperbolic sine function as hyperbolic cosecant x, that is nothing but 2 divided by e power x minus e power minus x. And similarly, secant, that is hyperbolic secant of x, hyperbolic secant of x can be represented as 2 divided by e power x plus e power minus x. So we have got 3, 4, 5. And the reciprocal of tan, that is nothing but cot. So hyperbolic cot of x can be given as e power x plus e power minus x divided by e power x minus e power x. We can represent the cosecant and secant of hyperbolic function like this. The cosecant can be drawn like this. Okay. So this represents the cosecant hyperbolic function. Right? So cosecant hyperbolic function. Cosecant hyperbolic function. So this can be represented as CSC also, h of x, cosecant hyperbolic function. And secant can be represented in this way. this secant, that is hyperbolic secant function of x. Similarly, we can arrive at the chord. So the chord will be like this. Okay, and here, so this is chord hyperbolic. Of x. Now let us discuss sine hyperbolic, that is hyperbolic function, sine function of 0. We already know that is e power x minus e power minus x divided by 2. So this is e power 0 minus e power minus 0 whole divided by 2, that is equal to 1 minus 1 divided by 2, that is equal to 1, that is 0 by 2, that is 0. Similarly, cos of, that is hyperbolic cosine of 0. So e power x plus e power minus x divided by 2. So e power 0 plus e power minus 0 whole divided by 2. That is nothing but e power 0, anything power 0 is equal to 1. So 1 plus 1 divided by 2, that is 2 by 2 is equal to 1. And we should also know the addition of sine of hx plus cos of hx. So this is equal to, we already know, e power x minus e power minus x whole divided by 2 plus e power x plus e power minus x whole divided by 2. So taking LCM, now we have this e power minus x plus e power minus x can be cancelled, and now we have 2 e power x. E power x, so 2 can be cancelled, therefore it is equal to e power x. Therefore sine of sine hx plus cos hx is equal to e power x. Now we try to find out the relation between sine hx minus cos hx. So that is equal to, so e power x minus e power minus x whole divided by 2 minus e power x minus e power, that is minus or minus plus, otherwise we will do later, e power plus x whole divided by 2. So that is equal to, e for taking LCM, now we have e power x minus e power x, and then minus e power x minus x, then e power x, and then minus e power minus x, right? So that is equal to, okay, so this becomes minus 2 e power minus x whole divided by 2, that is equal to minus e power minus x, right? We can also establish a relation between hyperbolic function and circular functions. We know cos theta is equal to e power I theta plus e power minus I theta whole divided by 2 according to the circular function. And sin theta is equal to e power I theta minus e power I theta whole divided by 2. So these have been discussed in detail in Euler's formula also. So theta is equal to Ix. Let us put like this. Okay. Now we can replace this theta by Ix. So cos of Ix is equal to e power I of ix plus e power minus I of ix. We know that is e I squared is equal to 1. Is it not? I mean minus 1. And here minus I into I. So that is equal to minus 1. That is plus 1. Therefore, cos of ix is equal to I squared minus 1. So e power minus x and minus of minus plus. So e power x whole divided by 2, which is nothing but that is the hyperbolic function of a cosine x. So cos of ix is equal to cos of, the hyperbolic function, cos function of x. And we can establish similarly that is sine theta also. Let us put sine theta, that is theta is equal to ix. So sine of ix, that will result I into sine h of x. How? Let us work out this. Sine of ix is equal to, so let us substitute here I of theta, that is ix minus e power minus I into, that is ix, and therefore whole divided by 2i. Okay, now e power I squared minus, so minus x, and then minus, now we have minus, and once again here plus x, is it not? That is plus x, because I squared is equal to minus 1, minus of minus plus 1, so plus x whole divided by, that is you have 2i. Okay, so whole divided by 2i. In this case, now let us multiply this by, multiply and divide by I, so that we are able to get I into e power minus x minus e power plus x whole divided by 2, and it becomes I squared becomes minus 1. So this becomes, now you can reverse this sign, otherwise you can put minus I into e power minus x minus e power plus x whole divided by 2. So now we can change the sign, or you can bring this minus inside, so that you are able to get, that is e power x, okay, e power, minus x plus, minus or minus plus, is it not? Now e power minus x, this is e power plus x, okay, this is e power plus x, and this becomes e power minus e power x minus x whole divided by 2. Of course you have I, right? We already know that is e power x minus e power minus x divided by 2 is nothing but sine hx, is it not? So we can put I into sine hx. Okay, so this is the third relation. Similarly, we can derive tan also. So tan of ix, so you can simply divide these two, so that you are able to get what? That is I of tan h of x, right? And what about the secant? That is, the secant is nothing but the reciprocal of this one, is it not? So you can put, that is secant of ix, that is nothing but the reciprocal of this one. So it becomes what? That is secant 1 by cos of this one. So secant of h of x. Okay. And similarly cosecant, reciprocal of sine. So cosecant ix can be given as what? That is 1 by I sine h x, is it not? So 1 by sine hx is nothing but cosecant hx, and 1 by I, once again you can multiply and divide by I, so it becomes I squared minus 1, so you can put minus I here. Okay.